welcome back and thanks for checking in. As we continue on in Unit 2, we are almost at the end. So a couple days here on this very last idea or this last lesson, and let's go ahead and get that started. In your textbook, if you care to look, it would be Chapter 5, Lesson 5 on page 248. It's called Multi-Step Equations, which should sound familiar because we've actually already practiced multi-step equations. But now we also are going to throw in multi-step inequalities. So this is day 1 of this lesson, and we will spend at least another day practicing this skill, right, of solving equations and inequalities that take maybe 3 or 4 or, oh my gosh, maybe even 5 steps in order to solve and get that variable alone. So on this screen in blue, I have for you the steps for how to solve a multi-step equation or inequality. First, if you notice that the distributive property is part of the problem, you need to distribute first. Then I would suggest that you get your constant terms together. Let's remember that constants are plain old numbers. Then we're going to put our variable terms together, right? The terms that have letters of the alphabet. And then finally, we will be isolating that variable, getting that grumpy, antisocial variable alone, right? Remember that variable doesn't want any numbers on his side of the equation or on his side of the inequality. Now, it looks like we're going to do maybe 7 examples, and I would really suggest that you take notes and write these down or take screenshots and print these out. Here we go. It says solve and check your solution. All right, I'm looking at on the top left here, it says 3 times the quantity d plus 2 equals 12. So this is an equation, right? It has an equal sign, and I see right off the bat there's distributive property. I'm going to take the 3 times the 1d, that gives me 3d, and 3 times the positive 2 gives me a positive 6 equals 12. Okay, now the next step would be to get my constants together. Constants are your plain old numbers. That would be the 6 and the 12, and the 12 cannot move, right? Because if you recall, you're not allowed to leave one side of an equation empty. So that means I need to move that 6 away from the d, and I'm going to do that by doing the opposite. I'm going to subtract 6, and goodbye to those 6's. I bring down the 3d, I bring down the equal sign, and 12 minus 6 is 6. Great. The next step would be to get my variable terms together, but I only have one variable term, so he can't combine with anyone. So the very last step then would be to isolate the variable. Get d alone and happy. So right now he's being multiplied by 3, and the opposite would be to divide by 3. And there go the 3's, and d is alone and happy, and 6 divided by 3 is 2. Now earlier in the directions it said to check your answer. We can do that relatively quickly. Go back up to the original problem, and where you see a d, if you put a 2 there, 2 plus 2 is 4, and 3 times 4 is in fact 12. That actually does work. So I checked my answer. Perfect. Good. Let's move on to the next one. Very similar problem, again with the distributive property. 4 times x is 4x. 4 times negative 3 is negative 12 equals 6. I look here. I need to move that 12 away from the x. Instead of subtract 12, we're going to add. I bring down the 4x, the equal sign, and 6 plus 12 is 18. Oops, I better put my next step. So the next step is that the x doesn't want to have that 4 attached. So instead of multiply by 4, you're going to divide by 4. Bring down your x, and 18 divided by 4 is 4.5 or 4.5. Which, if we were to go back and check our answer up here, 4.5 minus 3 is 1.5 times 4 is, in fact, 6. It works. So it looks like we're going to have some decimal answers possibly today. Oh my goodness, here's another one. Let's do this one on the far left side. 3 equals 4 times the quantity x plus 2. So I see distributive property here. That's 4x. And I see here, that's a positive 8. So now I take a step back here and I look and I see that I need to get that 8 over to the other side. So I'm going to do the opposite of adding 8 is to subtract 8, like that. There go the 8s. I still have 4x on the right. And 3 minus 8, watch out, that's a negative 5. Next step, to get x alone and happy, is to divide by 4. There go the 4s. It's going to be another decimal answer. Negative 5 divided by 4 is negative 1.25, or negative 1 1/4. Okay? So don't be surprised if you end up with some crazy answers. Oh my goodness, what changes here? I don't see an equal sign anymore. So now suddenly we do not have an equation, right? We have an inequality. So we have to be very mindful as we're doing this one that we keep that inequality symbol of less than or equal to. Other than that, the process is the same. Let's distribute the 4 to the b, which gives me 4b. And the 4 times negative 3 is negative 12. Look, there's that inequality sign. And 72. Okie doke. Let's see, who is moving? I think I'm going to move that minus 12, and I'm going to add 12. There they go. 4b, less than or equal to 72 plus 12 is 84. Look at that b. He doesn't want to be multiplied by 4. You do the opposite and divide by 4. Geez, we've been doing a lot of divide by 4s, I feel like. That's kind of curious. B is less than or equal to 21. That means B can be 21 or any number less than 21, like 20 or 19 or 18 or 0 or negative 1,000. As long as it's less than or equal to 21, that will solve that inequality. So those are some multi-step problems involving equations and inequalities and the distributive property. 3 more. Holy cow, I see distributive property on both sides. Not a problem. We've done these before. This is almost like round 2, isn't it? Okay, let's keep working. Let's do the distributive property first. 4 times x gives 4x. 4 times positive 5 gives positive 20. Equals 3 times 2x gives me 6x. 3 times positive 4 gives me positive 12. Okay, now we got all kinds of stuff going on. We need to get our constants together. This is where you have a choice. You can either subtract 20 from both sides, or you can subtract 12 from both sides. I'm going to subtract 12 from there and there. But you could really do either. It's up to you. Cross those 12s off. On the right, all I have left is a 6x. On the left, there's my 4x. And positive 20 minus 12 is positive 8. Now I need to get those variable terms together. That 4x on the left and that 6x on the right, those guys belong together. They're like terms. The 6x cannot move, right? Because he has to stay over there, because if you move that 6x, then you're leaving one side of the equation empty, and at this point, that's not allowed. So we're going to move that whole 4x term. Right now, it's plus 4x. So we're going to subtract 4x. Does this sound familiar? Do you remember doing this? We have. We've done this before. I have an 8 I have an equal sign. 6x minus 4x, 2x. Now, isolate the variable. Break that 2 off of the x. Instead of multiply by 2, we're going to divide by 2. So those cancel. X is alone and happy. Finally, it took a while. And 8 divided by 2 is 4. And you know what? You could actually go up and check this pretty easily. Go back up to the original problem. If x is 4, 4 plus 5 is 9, and 4 times 9 is 36. On the other side, if x is 4, 2 times 4 is 8, 8 plus 4 is 12, and 3 times 12 is 36. You get the same answer either way. Only 2 more. You say, only 2 more? Ms. Glusser, these are really long. Yeah, I know they are. Good practice, though. Good problem solving. Ready? Distribute, distribute. 5 times n, 5n. 5 times negative 3, negative 15. 3 times n, 3n. 3 times positive 7, positive 21. Let's get our variable terms, or our constants together. You can either add 15, or subtract 21, subtract 21. I'm going to add 15. I like that. (21 plus 15 is 36. Now, the 3n needs to move over to get with the 5n. So right now it's a plus 3n. We're going to subtract it. 5n minus 3n is 2n. And I've got 36 over there still. Great. Isolate your variable. Instead of 2 times n, we got to break that off by dividing by 2. 36 divided by 2 is 18. Final answer. Right? One more. You've been patient. Good job. Oh, this one's not even an inequality. Well, that's all right. Wow, on the left side, what do I see? What do I see on the left? Remember, this sometimes kids like this. Sometimes that helps. We should do that. I see that this 2 and this positive 10 could go together right off the bat. I'm going to make that a 12 plus 12m equals, now I'm going to distribute on the right. 6 times 3m gives 18m. And 6 times positive 3 is positive 18. Awesome. Now, I got to get my constants together. I can subtract 12 or subtract 18. Doesn't matter to me. Let's subtract 12. Um, 18 minus 12 gives 6. Okay, now I have to get that 18m over to the other side to join up with the 12m. Right now it's plus, so we're going to subtract. Divide those. I've got a 6 over there now. 12m minus 18 is negative 6m. Almost done. Isolate your variable. He doesn't want to be multiplied by negative 6, so we're going to divide by that negative 6. 6 divided by negative 6 is negative 1. All that work to find out that the value of m is negative 1. And if you were to go up to the original problem, plug in that negative 1, and do the order of operations, solve both sides, you would end up with the same answer. Okay? Multi-step, because there's a lot going on. And whether it's an equation or an inequality really doesn't matter. This is going to be the assignment that we're going to do in class. Not too many problems. Why? Because they're like super duper long. That's why. It looks like I'm asking you to show your work. Oh man, there's no decimal answers. Pretty nice, I guess. And it looks like you're going to end up with just one negative. So a couple guidelines there to help you as you're working through this assignment. Thanks for watching, and I'll see you in class.